name is Oveja. So I'm one of the member of the group one. So our main project for group one is for explorer. So for my part is I was in charge for the tree. So for our tree, we have basically we will use tree for the folders. So inside the tree folders, there's the nodes, which are the folder nodes, and inside each of the folder nodes, there's usually files. So we will look at files first. So in our file, we will store few data such as file name, file type, and size, and also the date created. So in our file structure, we have the constructor for it, and so the function for basically to show the file data in one go. So that's for the file. And we will now look at the three folder nodes. So for the folder nodes, we will store the file as I said earlier. And then you have the left and right. So by the way, our tree is actually a binary search tree, so that's why we implement the left and right here. So basically, the folder nodes left and right here will store the basically the nodes for the nodes, the folder nodes basically. So and then here we have a few functions that actually is recursive function for the implementation of some of the methods in the folder. So for example, the first one is destroy folder. So when this destroy folder function is called, you will basically destroy all the nodes for that is in the folder tree. And then next is for counting folder nodes. So you will basically go through all the nodes in the tree and return the value for the count. In here we actually use pass reference for the count. So we will basically pass the variable and then it will return back to that variable. And next one is for printing the folder nodes. So basically this is to print all the files in the nodes. So we will go through all the nodes in a specifically our tree will be going through in order. Since it is being stored, the nodes is being stored in order based on the file name. So yeah. And then the same thing with insert node. So for this inserting, there's few cases. So the first one is if there's no nodes in the tree, so it will create a new node and make it basically find the root to that node. And the next one is if the file name is equal to the same name as the node, so it will reject that and just return back to the basically return back to the previous code. And then the next one is if you will store based on basically the name. So the name is like abc. If it's a, if the root is like example b, if it's a, you will store in the left. If not, you will store in the right. So that's how this function works. And the next one is for retrieving nodes. So this is basically a ASC search function to search for the nodes that have the file name. So basically we will pass the roots and then pass the name, and it will search through all the nodes. And next is this one is for finding smallest. So this one will find basically the nodes that have the smallest file name, or basically like ABC, you will find the A. The file name will start with A basically. So this actually uses the next function which is the delete folder node. So for delete folder nodes there's a few conditions actually. So for the first condition is if there's no node in it, you will just return back. Then next is if the node name is if the node that we want to delete name is smaller than the root, you will basically pass, you will recursive with the left one, the left root, and this one is the same, you will recursive to the right root. But if it's the folder node that we want to delete is the current one, which is the current folder root. So if that node doesn't have a left file, or that doesn't have a left file basically, or it's delete, you will basically delete immediately. And then we go to this part, which is if it doesn't have if it's delete or it doesn't have right. So if it have a left root underneath, it will basically turn that left root to become the current root, and then you will delete the one that we want to delete. Else you will basically find the smallest one on the root and then basically replace with the current position of the nodes. So that's how the folder node works for inside our BST. And this one is actually is a function that will be using the archive actually, which is a queue that we will use. So it will basically go through all the folder. So basically this one is if we have a portion of the BSC that we want to delete. So like so basically like if you want to delete a folder, but you still want to archive the file in it, so we will use this function to insert it into the archive so that we can basically do undo function later to restore the files. So here is the actual class for the BSC folder. So in the folder there's the root to store the root pointer, and then also the string name for the folder basically. So next we in the folder, since our folder will also be used as a link a node for the linked list for folder list. So you will have the pointer for next. And here we have the constructor, disruptor, and method for getting a root. And then we have the folder name to return the folder name. And assembly to check if the folder is empty or not. And number of nodes is to return the number of files or the nodes basically inside the folder. And insert node is basically inserting the file. Delete node is the same. We delete the node that we want to delete. And lastly, is print folder is for printing the whole printing all the files inside the folder. So that's for the PST. Basically the three implementation that I did for this mini project. Okay, so now I will show the basically the output of what I've done. So in the main file we have actually implemented some of my basically the part that I've done. So I insert here, here. So we run the code. So here we have our menu. So for my part, it's actually for that written method for the three will be used in that insert basically of 5, 6, 7, 8, and also 9 basically. So and also one part of the 10. And then basically yes, so to showcase it, so we need the folder first since there's no folder here. So then now we want to try insert into the folder. So we just so we see that it's inserted successfully. So we can try to view it in, with the pass in the folder. So we can see that it's saved inside the folder. So if we try to insert this, actually try to insert the same file name again, we cannot insert file with duplicate file. So that is how we ensure that how we can search it properly. So we have that restriction for our pass. So and next we try to search for that, the file. So inside the direct folder and then look for the file. So this one is if there's no file name for file. So we will give an error, which is the file we find the file cannot be found. So actually the file that we're trying to that in the file is not picked, right? So now traffic. So there we go, it will return the basically the file, the name file name. So that we use PST version. So and then we try to delete it. So delete it from the JL file and then delete it. So there we go. We successfully deleted. So now I try to so inside I'm actually it does use insertion, so we will insert back into the folder. So now in the file is back in there. So let's pick back again. So if you try to delete the file that's not in there, you will also give a error that shows that the file is not saved. So that is how the error is handling it. And then let's also move file to another folder. So currently we only have one file, I think it will work. So yeah. So inside here, so we will move directly just basically the same place. But so in moving, we actually just use the insertion and deletion from the original folder. So basically, you insert the new folder and then delete from the original folder. So that's all, and thank you.
Hello, my name is Hamiza. Today I will like to present for my part, which is linked list and search for folder and folder list. So first is this is the folder class, which we, as you can see, is already have the node. And next is going to for the folder which for the head pointers. And finally for the transverse linked list that I did from head to null, which is this folder. So nextly we're going to go straight forward to the output in the system. So as you can see, this is our system. So the first one is going to create a folder. Like let's name our folder is documents. Okay, then we're going to display all the folder in the system. So see, the document is added inside the system. Next is going to search a folder, certain folder. So what folder we want to search? For example, is like Apple Music. So see, it shows the folder name and number of file in the Apple Music. Finally, the next one is deleting folder. So here we want to delete the folder that we created, which is documents. So the document delete successfully, and finally going to do the transverse link folder list, which is linked list. So we can pick 12. So this is the final output for the linked list for transversing, which shows from head to null. So we already deleted the documents. Therefore, you only have two folder in the file explorer now, which is Apple Music and Captures. Thank you very much. That's all from me.
Good day, Doctor. I'm Dan Jian Singh, and right now I'm going to explain about how we implement the queue in our code. So the archive node struct contains a file object f and a next pointer to link nodes. The constructor initialize the f with the pass file parameter and set next to now, creating a standalone node ready for the queue. So for the archive constructor, the archive class has two pointers, the head, which is the front of the queue, and the back, which is the rear of the queue. So the constructor initialize both to null, creating an empty queue. So for the archive destructor, the destructor traverses the queue using the current node starting at head and save the next node address in the next node, then delete the current node, move forward and repeat until all nodes are free. Then finally, it set head and back to null. So for the is empty function, it returns true if both head and back are null, which is empty queue, and false otherwise. So this prevents the error when typing to the queue from an empty queue. So moving on to the insert archive function, we first create a new node with the file data if the queue is empty. So both head and back point to the new node. Otherwise, it links the new node after the current back and update back to the new node, adding element to the rear and maintaining before order. And for the retrieve archive function, we first save head in the temporary and move the head to the next node, extract the file data from the temporary, delete temporarily, then set back to null if queue is now empty, and return the file, which is removing the element from the front in before order. So for the delete archive function, it will loop through all nodes starting from head and save each in temporary, then move to the next node, delete the temporary, and continue until all nodes are free. Then reset the head and back to null for clearing the entire queue. And the archive object is stored inside each action to keep the data needed for undo operation. When actions such as deleting a folder, deleting a file, inserting a file, or moving a file, the affected file data is first saved into the archive, and this archive is passed together with the action into the undo stack. So this allows the undo system to restore the previous state by retrieving the stored file data and reversing the operation based on the action type. So right now, let's run the code and see the example output. So first, I will choose the option 1 and to create a folder named year 2001. And right now, I will choose the option 5 to insert 3 example files into that folder. And right now, I'm going to delete all the files in that folder. So we choose option 7. So right now, all the file has been deleted in that folder. So we try to undo the action. So we choose the option 10. So when we choose the option 10, the file deletion will be reverted. So we try to undo all the files. So right now, let's check whether the file is reverted or not. So as you can see, we undo all the action and the file appear back in the folder. So I think that's all for my part. Thank you.
So hi everyone. So for this part of the project, I will explain the state data structure and how it is used to implement the undo functionality in our simulated file explorer system. So the state is used to store user action so that the most recent action can be undone first, following the LIFO principle. So why is that used? Because we choose that because undo operations naturally follow LIFO behavior. For example, if a user create a folder, then insert a file, the file insertion should be undone first before the folder creation. So each time an action is performed, we push the action into undo stack. And then when the user select undo, we pop the most recent action and reverse it. In our code, the stack is implemented using a linked list. So the undo stack class contain a pointer called top, which always point to the latest action. And then we have push function to store action. And then we have pop functions to retrieve the latest action. So each stack node is an action structure which store the type of action, which is create folder, this one. And then we have delete folder and insert file, delete file, and move file. So an archive pointer to store file for undo recovery. This allows us to undo different operation using single stack. Yes. So how undo work in delete file is when a folder is delete, we cannot simply recreate an empty folder during undo. So before deleting the folder, all files inside the folder are stored inside an archive queue. So this archive is saved together with the delete folder action in the stack. And then when undo is triggered, the folder is recreated. So all archive files are retrieved from the queue and insert back to the folder. So this fully restore the folder to its original state. This ensure data consistency and prevent file loss. So undo for insert file function is to remove the inserted file. For delete file, undo restore the delete file from archive. So for move file, the undo function is to move the file back to its original folder. So each undo operation use the store action information to reverse the exact change made. I think that's all for my coding. So I will show you my output. This is the output for my save action. First, we create the folder, and then I insert the file into the folder, which is this a file. Next, I insert another folder, and then I delete the HCI folder, and then so HCI folder is successfully deleted. And then if I enter number 10 option, which is under action for create, delete, insert, and move, so the folder SI is successfully recreate. So it's mean the deletion is revert lah. And then next, I display all the folder in the system. So HCI folder still here, even after I delete because I choose option number 10. And then I want to move file to another folder. So I want to move file from the SA to HCI. This one, I want to HCI. So file chapter 1 is successfully moved from folder DSA to chapter 1 to HCI. So after I move the file from DSA to HCI, and then I choose the number 10 again, and then the file movement is reversed. So the file is revert into the DSA file. So this one. So this the file is moved to DSA file by after I choose the option number 10. I think that's all for my part. Thank you.